Okay. So with inverse functions, the -1 does not mean 1 over. It's not an exponent, it's a matter of notation. And as we looked at last, well, I think it was chapter 2, we had inverse functions. And like Michael said, you switch the x and the y, your domain and range are switched, okay? And what was the purpose of all that? What did it do?
On a graph, it like flips it over the line y over x, right?
It flips it across the line y equals x, yeah. Good. What else does it do? Like, if f of x equaled 3,
Make it
then if I took the f inverse of 3,
1/3.
what would that give me?
1/3.
1/3. No.
Negative.
3 over x?
I don't know.
No?
Negative 1.
If x goes to 3, then the inverse is going to take 3 back to x.
It's just 3. So you get the same answer.
No, what it does is the function and an inverse function undo each other. Okay?
Oh, so f of 3 gives you x.
F of x is 3, so f inverse of 3 takes you back to the x. Okay? Yes. Let me give, those are all markers. Let me give you one of these. So we're talking about what a function, inverse function, does. When you take the tangent, actually let's do one that we can do a little bit easier with our unit circle. When I take the tangent of, or sine of pi over 6,
30.
30 degrees.
it's 30 degrees. What is sine of 30 degrees?
It's one half.
1/2, okay? So if I'm going to do the inverse sine,
2.
no,
Oh.
Is it pi over 6?
Pi over 6.
that equals pi over 6.
Oh.
An inverse function will undo. Now here's the thing. When we had polynomials and stuff or lines, we could just switch the x and y and we were able to solve it, okay? Sine, because of it's this trig function, it's kind of hard to, you can't just switch an x and y and figure it out. You have this other function, the inverse function, but what happens is the same. We start with an angle and sine gives us a value related to that angle, okay? The inverse sine takes that value and returns us back to the angle we started with.
What if you did inverse sine of pi over 6?
Then it would give us an angle that had a sine equal to whatever pi divided by 6 was.
Oh, so it gives you that.
Yeah, pi over 6 wouldn't be an angle in that case, it would just be a number. So,
Are you taking our midterm on Thursday or Friday?
it is Thursday. We'll talk about that a little bit later here. So, that's what an inverse function is, and we're getting a little bit ahead, but that's okay. How could we tell by looking at it whether a function would have an inverse function? You remember that?
It has to be even.
No?
Positive.
How could we tell if a graph was a function? to begin with?
The vertical line test.
The vertical line test, okay? So then how did we tell if it would have an inverse function?
Horizontal line.
Yeah, horizontal line test, okay? And that's because when, as Nick said, we reflect it across the line y equals x, if it doesn't pass the horizontal line test, then when we flip it, it's going to fail the vertical line test, okay? So as we look at our three main trig functions, okay? This red one here is our sine curve, the blue one here is cosine, and you've seen this green one, tangent, briefly, okay? Which of those has an inverse function?
There. If you
Think about it.
tangent.
Do any of those pass the horizontal line test?
No, no.
No.
Tangent. But for one of the,
You're
But
thinking-
that's
you're
one
doing
function.
vertical.
Wait, for what?
only for like one of the sections of
One of the sections, what do we call those?
Periods.
the period.
Yes. Alright, so what are we going to do? We're going to limit our domain to one period. And then we can actually look at an inverse sign. Okay? So that's what I want to kind of develop here. We're going to take these one at a time. Alright? You guys know this already. We have sine. Its period is 2 pi. The range goes from -1 to 1. Okay, the domain is all real numbers. How could we limit the domain?
Put an asymptote for the
X. Make the
x is
period.
less than or equal.
You ended at pi over 2.
2.
That's not it. Well, yeah. You can say X is less than pi over 2.
Okay,
Less than or equal to.
if we stopped it at pi over 2, and on the left side, where would we have to stop it?
And negative pi over 2.
There we go, negative pi over 2. Okay? We actually can't even include a full period. Alright, because that period would fail the horizontal line test. See? I mean, if I, the original first period goes from 0 to 2 pi. Well, if I drew a line across, I'm going to hit that twice. Okay, so that fails the horizontal line test. What I've got here, though, now, is I have defined a particular domain for sine, okay, going from negative pi over 2 to positive pi over 2. Okay? So then it's a matter of trying to visualize this. What is this going to look like if I then reflect it across the line? Remember we had that line, y equals x. Okay? Here's our line y equals x. What's that going to look like? Well, get rid of that. It's going to look like this. Okay, and I want to look at some features of each of these.
What is
Okay.
arc sine?
Arc sine is the same thing as the inverse sine. Okay?
Wait, how's that the same thing?
It's just different notation for the same thing. Okay?
Why would you make it confusing? No, why not just label it?
Well, because some people think because we have cosecant, and cosecant is the reciprocal of sine, to avoid messing with.
Oh, like
Because
the
it
X
looks
and
like
Y.
an exponent and
Yeah.
it's confusing.
Wait, so the X and Y values switched, right?
Yes. So you'll notice now,
Looks like
what was our range was -1 to 1. Now our domain is -1 to 1. Our domain we had limited to negative pi over 2, pi over 2. Now our range is negative pi over 2 to pi over 2. Okay? And you'll see that actually passes the vertical line test then. Okay?
What is our mid-year assessment?
We'll talk about it later.
Oh, okay, I'm sorry.
So, no, that's okay. Alright. So, that's our inverse sine function, arc sine. Okay? It's also called arc sine because we have the unit circle, it's related to arcs and anyways, but it's just different notation. So here we have cosine. How could we limit cosine so that it doesn't repeat? Or so that it passes the horizontal line test?
We can do this, not the same one. 0 to pi.
Yeah. If we go from 0 to pi, it will pass the horizontal line test. Okay, so we're going to limit our domain so that x goes from 0 to pi. Okay? So, tell me, what's the domain of our arc cosine going to look like?
Negative 1 to 1.
Negative 1 to 1. What's the range of our arc cosine going to be?
Negative 2.
0 to pi.
Oh,
0 to pi. Okay? 0 to pi. That's what that looks like. Okay?
Isn't that just taking the first one and flipping it over the line?
It is. It's flipping it over the line y equals x. So the point 0, 1 becomes the point 1, 0. And the point pi over 2, 0 becomes the point 0 pi over 2. And the point pi negative 1 becomes the point negative 1 pi.
Excuse me, Mr. Hickson, you will put this video in Skyway? Like, you're recording
Yeah.
okay.
Alright. See if you can't figure out tangent.
Oh, that's lovely. You can do negative pi over 2.
Till then, pi over 2.
Put pi over 2.
Yeah. And in this case, it won't actually be equal to, we'll just have an open interval here. Because we have asymptotes at negative pi over 2 and pi over 2. Okay. So, what?
How do you get the range if it's negative infinity 2?
Well, let's think about that. For the inverse tangent, what would the domain be?
Negative infinity 2.
Yep. And what would the range of the arc tangent be?
Tangent to the negative. Would it still be infinity?
No, because if you keep going up, you'll hit another tangent thing. You could do like negative pi over 2, pi over 2.
Yeah. Remember, the domain and the range just switch when you do an inverse function. Okay? So you look here, and instead of having vertical asymptotes,
You have horizontal.
we now have horizontal asymptotes. Okay? Our domain is all real numbers now instead of the range, and our range goes from negative pi over 2 to pi over 2. Okay? By the way, what function does that kind of look like?
One of the growth
Oh,
functions.
Yeah.
what's it called?
Exponential.
No, exponentials like this.
Logistics.
Was it
Logistic.
Yeah.
Kind of looks like a logistic function.
I'm on
Okay.
fire
So, yeah. Logistic functions are sometimes called S-curves. but, cause they're also known as sinusoidal, because they kinda look like an S, but the arctangent kinda looks like a logistic function, okay? Now, I wanna do something, get your calculators out real quick. Okay, everyone get your calculator out. I have a little exercise for you, okay? Put your calculators in degrees, okay? And we said that back here, you would take the inverse or the arc function of the value in order to get the angle, okay? So for example, I know you could do this using the unit circle, but what are you going to put into your calculator?
The inverse sine of 0.0.5.
Couldn't
Yeah.
you just put the cosine of
No. So you'll hit second sine, inverse sine. Okay, everyone needs to be doing this on your calculators.
30.
Okay? And you should get 30. Did you guys get 30?
Wow, man.
Are you in
Yes. Now,
Yeah.
you're going to need to put the degree symbol in there.
Okay.
Or, actually,
Wait, sine negative.
you need to get it to.
second?
Where's your brain seat?
Like a second good?
Yeah.
You put sine to the negative.
Second.
I had work though.
CJ works for minimum.
Yeah, everyone works.
CJ, do you work at a, work at a
Good for you,
Wendy's?
you don't work.
Yeah, I do.
Where do you work at?
Play with the band.
That's not work.
Yeah.
Teaching music lessons is work.
Yes, it is. We get paid.
You can multiply by 180.
I
and
charge,
divide by
I
pi.
charge 30, 40
don't like
an hour.
Yeah, you can do
That
that.
goes your whole career.
I know there is a function.
No one
You
can say
probably
that's
be the
just
most
not
information
I
teacher.
got like
There is a
$75.
function where you can change it.
Michael would not be a patient.
I actually am, like, I'm not kidding,
Like,
Yeah,
when
and you
it's,
slowly start sneaking in like that.
I think I'm getting
Yeah,
sick. I'm pretty sure I'm getting sick.
I could teach.
I was like,
it's a paycheck.
bro,
If there's money involved, I will be
Yeah, I
like
pretty
the
much looked
nicest
like one
person
too.
ever.
My hair was like,
And I'll do pretty much anything.
Yeah, so
mine was all
Yeah. Is there a problem with that?
I was like, oh, she's sorry.
She was so nice to me when she came to these areas. She saw me, and then she saw me like this.
Really?
She thought I was like
Are you
scared.
That's pretty intense.
Awful.
Well,
I can't flex my teeth.
Well,
It
you
doesn't
need
work
to
with
get
us anymore.
you can calculate.
It's like,
how much do you get for it?
Workout, so he's like, $10 50 cents an hour.
And
No,
then
I take it
20
out before the break, but I'll take her like 20%.
Now yours is a degree.
Oh, I know.
Oh, good. Hey. Do any of you with the Inspire not know how to set it to degrees?
Show me that you need to hire.
Don't stop, don't stop.
I made $67.
I like it, my freedom.
I have a question on the end score.
Here?
Not really, like.
I don't know, I'm trying to set up like a
I was
calculator
squatting like
emulator
90.
on my computer right now.
He's
because I
like,
don't have
Oh, up on the
No, it's
little
not, it's
pad.
not, shut up.
It doesn't.
Well, I mean,
I
that's
was like-
and I wrote it, so I don't
I
trust
almost like,
Well, it's
hot
like a pet.
blood vessels.
Pencil and
He's like, nah, that was easy. I'm like,
Mine is here.
okay.
Yeah, he's like, you wanted me to jump 15 pounds, like when I barely finished my set, he's like, alright, try
Here,
to
look.
He's like, where's my phone?
Are you kidding?
I'll show you on mine. I don't
When you're done, can you go?
Okay.
You
Tell you what, if you've got that, go ahead and find the rest of these while we get others
Mine's
set up.
Mine is on the battery, handheld setups, and then it's like the third option.
Greener, definitely the best in the grades.
Like I think I
Oh,
found this picture.
okay.
It
Hang
should
on.
be around there.
I like red.
Go back to your
I like
home
green is
screen.
amazing. I don't
Go
know
back
why
to your
green
home
is so- I feel like green is so much better than every other color.
in settings, number 5, you
They're
can
barbell.
actually just type
I
in
hate
number
barbell
5.
and everything else.
And then
I think there's a movie where
document settings,
Here, look.
and
50
then
bucks.
you can change the angle to degrees.
Mine is just on top, I think it's because I have a different software.
Yeah, you
So
would.
Mine is
do
older.
you get that every day? Do you get that every day?
No.
No, because I do.
Once a week.
Yeah, whatever.
He's doing $50. You get it every day, so not like every week.
See, the difference is he doesn't sit around playing your ego there.
Yeah, well,
Go more
because
to
I
like-
can literally sit down and play video
And
games.
then don't put the degree sign.
No, you cannot.
Okay, you're
Yo.
right, I'm wrong.
Read.
Oh.
You get that right, right?
Alright, did everyone get 30?
How did you do
Yeah.
that? Did you just do
Yes.
No.
You can't get that to work.
I will not let
Sorry.
anyone, like, whoever I'm doing.
Okay, okay.
Alright, so
No, I'm good.
you got 30.
I still
Okay.
had-
Yeah, but it doesn't.
I keep getting 52.
The answer's 42.
Oh, because I think you're in
How's
Scratchpad.
your space?
Go to a new document.
Subline.
Got one.
No, over the bridge, I was just like.
What are you doing?
Hang on.
Vegas though.
No.
Like Tarzan.
That's just like a writing
I
document.
don't even know who
I-
Sorry,
I have no
I
idea.
can't quit video games.
I had no idea.
No, like,
You know who that is?
Add
when all of a
calculator
sudden
to
you
new
do
all-time
document.
basketball.
And now you
Never
can.
heard of him.
Never heard.
oh,
Must be dead. Yeah.
CJ, what would you do if you had to quit video games?
Now it is
There you
on
go.
option.
Okay, so what do we get for, what do we get when the cosine is 0.7? What's x?
45.
7-6.
45.57?
Yeah.
So 45.6, right? Guys, we need to make sure that we're rounding, okay?
Yeah, I didn't know how much you wanted us to round.
Yeah, I know.
No, that's okay. I just,
Inverse.
if it's 45.57, don't say it's 45.5, right? Round it.
Okay.
We don't just chop numbers off. Make sure you round. What if the tangent is negative 8?
Negative 82.9.
That looks a lot like gradients.
You were a little bit faster.
Okay, negative 82.9. How about if the sign is a negative 0.8?
Minus 53.1.
Minus 53.
Minus 53.1?
Yeah.
Okay. What if cosine is a negative 0.2?
101.5.
Okay. And how about if tangent is negative 2.3?
Minus
Negative
66.
6. Yeah.
Minus 66.5. Now I did this earlier, so let's take a look at my answers. Alright. I got 45.6.
Huh? Oh, because you subtracted it from 36.
Okay. So there's a variation. Now, hang on. With tangent, we went between negative pi over 2 to pi over 2, which was negative 90 to positive 90. This is outside of 90, right? Punch in tangent of 277.1.
Isn't it just 360 minus 82.9 gives you 270?
It is. They're coterminal angles, so they should have the same tangent, right?
Yeah.
Did you get negative 8?
Yeah,
Or
or negative 8, yeah.
rounded?
Yep.
Okay. Well, you can see here, obviously there are angles beyond what we limited the domains to, right? So, in this case, we have a coterminal angle, alright? Again, we have a coterminal angle with sine, okay?
Under
What about with cosine here?
58.
258.5. Now that's not coterminal. What is that though?
Because,
No.
well, it's like you subtract 360.
Guys, think about this.
Supplementary.
You
You've
subtract-
gotta, listen, you've gotta understand this part or you're gonna be really lost the rest of the stuff we're doing with Trig,
Supplementary.
okay? They're not supplementary,
I have
they'd add up to 180 then.
360.
They do add up to 360
So
in this
how-
case,
I'm so
but,
confused how we got.
Why are they not coterminal?
well, cause they're not 360 apart.
Oh.
So think about it. What do we know about cosine?
It's
Where is it negative?
In the third, no. Wait, cosine.
in the bottom, this one.
The third
It's like 1, 2, 3. Yeah.
one.
In the third quadrant
And the
and?
fourth.
Oh, in the
Fourth also.
No.
Second.
second, third.
Second quadrant.
Second.
Second and third quadrant. 101.5 is in the second quadrant, right?
So shouldn't
This is in the
third.
third quadrant. So when I'm told that the cosine is a negative 0.2, there are actually two possibilities for what my answer could be. In fact, for all of these, there are two possibilities. Because sine is positive in the first quadrant and the second quadrant, right? So not only 30, but 150 is an answer that would give me a sine equal to 0.5. Okay? Cosine is a positive in the first and fourth quadrant, so 45.6 and negative 45.6. Okay, or what would that be? 314.4. Those would both have cosine equal to 0.7.
What's the reason for that? Because they're
Because remember, all students take calculus, okay, with our unit circle. All the trig functions are positive in first quadrant, sine's positive in the second, tangents in the third.
so like for the third one, because it's negative 82.9, that's the same thing as 2.
Yes, that's the same thing. Those are both in the fourth quadrant,
Oh, okay, I
but
see.
that actually gives us what? What's 82.9 there?
It's your code. No, what's it called?
That's 80
It's your reference angle, isn't it?
reference angle, yeah. So if we went 82.9, where else is tangent negative? Over here in the second quadrant.
So it's the same. It's the same.
If we
spot.
use the same reference angle, you know, we would get, was it 96.1 or 97.1 degrees. That would also have a tangent equal to negative 8. Okay?
What about the fifth one, where it's 101?
101.5 here.
Wouldn't it have to be a negative 2?
Well, no, because think about where is cosine negative? In the second quadrant, there's 101.5, and it's also negative in the third quadrant. There's the 258.5. Okay? Because cosine is a negative value in both the second and third quadrant, so there's two possibilities.
So as long as it has the same reference angle.
Yes,
It's all about referencing.
it's all about reference angles.
So right.
Yep.
Jose.
Okay?
They both right or how did you
They're both right, that's the thing.
So the reference angle.
They're both right. The reason why I'm telling you this, guys, and you know, same thing for this last one, for tangent, you know, you could have gotten a positive 113.5, you could have also gotten 293.5. Because tangent is negative in the second and fourth quadrants. Okay? The reason why I did all of this is because I want to make sure that you guys see that, especially when you're finding angles like this, you can't just punch it into your calculator and blindly write down whatever it spits out at you. You've got to think about the whole situation.
What's
Okay?
the reference angle then for 5?
For 5, well, if you're at 101.5, you would think, okay, that's second quadrant, so that's short of 180 degrees.
31.
So 180 minus 101.5, 78.5.
Wait, I'm doing it the wrong way then, so it's,
Yeah.
Yeah, some of you did that on the test. You were finding this angle for a reference angle, and that's not right. The reference angle is always from the x-axis to your terminal side.
okay.
Alright? Is that making sense?
Excuse me, can you explain number 2, please? One more time.
Number 2?
Yeah.
Okay. When you just punch it into your calculator, you get the 45.6. Okay? Where else is cosine positive, though, Gleb?
In the 4th quarter.
In the 4th quadrant. So, that 45.6 is our answer from the 1st quadrant, but it's also our reference angle. So, that 45.6, I'll go back up here again. Here's 45.6. If I go 45.6 this way, then that gives me my 4th quadrant angle. That would be another possible solution. So 360 minus the 45.6 would give us 314.4. 314.4 degrees would be that angle. So there are 2 possibilities for this equation. 45.6 or 314.4 degrees. And that's what I was saying, with all of these, there are actually 2 answers.
Except for tangent, there's 3.
Okay? Well, two different positive answers.
Oh.
All of them. We could keep going with coterminal angles forever. But yeah. So, but the whole point of that is, guys, I don't want you to just blindly write down whatever your calculator gives you. Okay? You have to think. And that's what can make this a little more of a challenge. Especially when you're solving a triangle, you're supposed to find an angle in a triangle and you get negative 53.1. And you're like, hey, what's the deal here? We can't have a negative angle in a triangle.
It's definitely.
So you have to work it out, okay? Yes. All right. So any questions about that?
Would you rather us give you the if we get a negative answer, give you the positive one?
Just follow the directions. A lot of times what the directions will say is they'll say find x between 0 and 360 degrees.
Oh, okay.
So they're telling you, first of all, they want you to use degrees, and they're also telling you give all the answers between 0 and 360. So if you get a negative, give a positive one, so.
Gotcha.
So,
Thank you.
for number 3, what's the referencing?
Well, you tell me.
Is it like just past 270?
Well, 277 it is in the 4th quadrant. It's past 270.
Okay, so it's 277 the reference angle.
No, reference angles are always acute.
It's 82.
What?
Yeah, it's 82.
Yeah, reference angles are always acute and they're always positive. So if you get negative 82.9, the reference angle is positive 82.9.
Okay, got it.
Okay. Now, if you look at all of these, okay, here's all 3 graphs together. All right, we have the sine, or the arc sine. We have the arc cosine.
It's like
and then we have the arc tangent. Okay? And you'll notice our y-axis is now has the pi's on it, or the degrees if we're in degrees. The x-axis is now the 1, 2, 3 values. Okay? So this isn't something I'm going to ask you to sketch, but it is helpful to recognize what those look like. So what I want to do with the remainder of the time, I know this is a little bit different and we're coming off break and we're a little rusty with things, but what I want to do is actually use the time that we have remaining, which is a decent amount of time, and work through the homework problems that I have listed here together. Okay. Here's the thing. All of these, notice it says without using a calculator. You should be able to do all of these just by knowing the unit circle. Okay?
Or is it just,
What?
it's not matching, no.
No, it's not matching. There's two parts to each one.
Oh, I see.
So, there's some vocabulary, okay, which is getting used to the different notation, getting used to the domain and range of your functions, and then these as well. Start with these. I want you to work with a partner. Try to do it without looking at the unit circle first. Then get out your unit circle and check yourself. Okay? And then, obviously, once you have those, you can go on to the other problems as well. Okay? I'll leave these problems up here so you can see. But go ahead and get with somebody now, and let's start working through these. I want this time to be a really productive time to get us back in the groove here working, and also to really nail this part down. Okay? So let's go ahead and do that.